I wanted to show you some cool tricks and shortcuts for parallel resistances. Starting with, what if you have two resistors that are identical and they're in parallel? So here's a drawing of that right here. Two identical resistors that are wired like this in parallel. So if you have that, I want you to take a look at this in terms of, let's look at it from over here at this end, like we're looking into the end of the resistors. I've drawn one of the resistors just like as a wire of this cross section right here. So it's as if this thing has this cross section right there. If I add another resistor that is identical to it with the same cross-sectional area, again, I'm looking at it from the end, notice that what I'm doing by putting two in parallel is I am doing what to the cross-sectional area? I'm doubling the cross-sectional area. What will that do to the overall resistance? It halves it. As you may recall, the resistivity, or the resistance rather, is equal to the resistivity times the length over the cross-sectional area. So if you double it from this to this and this, you're effectively halving the resistance. So what is R equivalent of these two R's? Is just R over 2. That only works for identical resistors in parallel. Here is another cool trick that you can use for resistors in parallel that I'll derive for you right here. Notice that our general parallel resistance, R equivalent for parallel, is equal to 1 over R1 plus 1 over R2. This trick only works for two resistances in parallel. I'm just going to quickly solve this by finding a common denominator and just going to get to the result at the end here. So notice for two resistors in parallel, it only works for two, it's way more complicated with three, but for two resistors in parallel, all you got to do is find the product of the two and divide it by the sum of the two, and that'll give you the equivalent resistance. So a couple of shortcuts that'll help you, especially on multiple choice questions on the AP exam.